So today we are talking about the techniques of the integration. It's like how we have techniques for the derivation, we have a techniques for the integration. Now look at this one here. The derivation of x cubic is 3x squared. So what does it mean? That means the integration of 3x squared will be x cubic plus c. The derivation of square root of x is 1 over 2 square root of x. So the integration of 1 over 2 square root of x will be square root of x plus c, like they are opposite to each other. The derivation of tan is secant square. So the integration of secant square will be tan. And the derivation of u to the power 3 over 2 is 3 over 2 u to the power half. So the integration of 3 over 2 u to the power half will be u 3 over 2 plus c. This is just an introduction, or like what did you say yesterday, how the integration is an inverse of derivation. Now let's come now to talk about.
Teacher,
Yes,
should we memorize these formulas?
these, and I will start now with the formulas. This is just like examples.
Okay.
Let's start now with the techniques of the integration. Let's start now with the first one here. Now, all of us know that the derivation of x is 1. So, the integration of 1 dx will be x plus c. The derivation of 1 is x plus c. Don't forget plus c. Why? Because the derivation of x is 1, so that the integration of 1 will be x. Now, also, if I'm asking you about the derivation of x to the power r, in the derivation, we said if you have x to the power r and you want to find its derivation, you will say it is r x r plus 1, or minus 1, sorry.
Minus.
So here, it is rx to the power r minus 1. So like the differentiation, I count back the exponents. If it is a cubic, it will be squared. If it is squared, it will be to the power 1. So I count back the squares in the exponent, sorry. But here in the differentiation, I count on. What does it mean? That means x to the power r will be x to the power r plus 1. So I will take the exponent, add to 1, and I will divide it by the new exponent, which is r plus 1. X raised to the power r plus 1 over r plus 1. Don't forget plus c. Except r equal negative 1. Later on, I will talk about it. So only if r is 0 or negative 2 or any numbers except negative 1, I will use this formula, x raised to the power r plus 1 over r plus 1 plus c. So here, like, you count on the exponents. If you have x squared, after differentiation, it will be x cubic over 3. So you count on, or you increase the exponent. Let's have an example here now.
Teacher, it will be r plus 1 or minus 1?
Plus 1. For the integration, it is r plus 1 over r plus x raised to the power r plus 1 over r plus 1. What is the integration of x cubic? What is the integration of x to the power 4? What is the integration of x to the power negative 3? Now, before integrate them, when an derivation, I told you that you have to write d over dx
The XR.
yeah بس please. And Erwin, Shahid, there's no request here for Shahid. Ask her to join.
Okay, تمام.
So here now, d over dx, before that, when I told you about in derivation, it's like the derivation to dx. I want to find the derivation of any function which is relative to x. Here also, when I want to integrate x cubic, why I write dx? That means I integrate to x, like the derivation here. Let's now find the integration. X cubic. We said we will write x, then I will look at the power. Where's the power? It's 3. So I will put this 3. I add it to 1, and then I will take this 3 plus 1, and I will write it down. Plus c. Okay? And so it comes like 1 over 4 x to the power 4 plus c. This is an integration of x cubic. 1 over 4 x to the
So
power.
should we write it 1 over 4x to the power 4?
Why? Sorry?
Should we write like this 1 over 4x to the power
Yes.
4, or just
Yes.
leave it?
No, write it as 1 over 4 x to the power 4. Look at the second one here. X to the power 4 dx. Here we have x to the power 4 plus 1 over 4 plus 1 plus c. I just add 1 to the exponent, and I will copy the new exponents and write it in the denominator. So it comes like x to the power 5 over 5 plus c. The third one. Here we have x to the power negative 3. Say x to the power negative 3 plus 1 over negative 3 plus 1 plus c. It's like x to the power negative 2 over negative 2 plus c. And we can simplify it later on, I will tell you. So this is for the integration of x to the power r. Is it clear?
Yes, teacher. Yes, teacher.
Yes.
So x raised to the power r plus 1 over r plus 1. Let's talk about the third one. Now, we know that the derivation of sine is cosine. So that means the integration of, so here you have the opposite. You must distinguish between the differentiation and the integration. We know that sine is cosine. So the integration of cosine is sine. The integration of cosine x dx is sine x plus c. And the derivation, the integration of sine x dx will be negative cosine x plus c. So you can write the differentiation, the techniques of differentiation, and then make the opposite, or you can memorize the integration only. So the derivation of cosine is sine, and the derivation of sine is negative cosine. Be careful. Here, we said before, the derivation of cosine is negative sine. Here now, and I told you before, the derivation of any trigonometric function starting with letter C is negative. Here, the derivation of any function starting with letter C is positive. The differentiation of any trigonometric function like dy over dx for cosine is negative sign. And for cotan is negative tan cotan. So I mean that if you have c, you have a negative sign. But for an integration, no, the integration of anything starting with letter C will be positive, and the other will be negative. So the integration of cosine is sine, and the integration of sine is negative cosine. This is for sine and cosine. Now, let's talk about tan. The integration of secant square is tan. Not secant only, secant square. So, the integration of secant square x dx is tan x plus c. The integration of secant square is tan. And also, the integration of cosecant cosecant square x dx will be negative cotan x plus c. So the integration of secant square is tan, and the integration of cosecant square is negative cotan. As I told you, you can write the table for the differentiation and write its opposite in the integration. So the derivation of cosine is sine, of sine is negative cosine, of secant square is tan, of cosecant square is negative cotan, of secant tan is secant, since the derivation of secant x is secant x tan x, so the integration of secant x tan x is secant x plus c. And the last one here, the derivation of negative cosecant is cosecant cotan. So the derivation, the integration of cosecant cotan is negative cosecant plus c.
Teacher,
Yes?
can you go back to what you raised?
Here?
Yes, teacher, didn't you say no, if it starts with C, it will be positive?
Yeah, it is a wrong formula. That's
Okay.
wrong. Forget this one. It's work only for the derivation. So here, let's now. So the derivation of sine, the derivation of cosine, the derivation of secant or tan secant, the derivation of negative cosecant x cotan x, the derivation of
derivation or integration?
Integration. Sorry. What also we have here? Tan squared or secant. Oh yeah, secant squared x and integration of cosecant squared x. Now, what is the integration of sine?
Cosine.
Cosine x plus c. Of the cosine,
Sine
what
x.
is the integration of cosine?
Sine
It is negative
x plus c.
Negative sine x plus c.
Teacher, you said this is in the derivation. Negative sign only in the derivation.
Teacher, the opposite.
Yes, teacher, it is not negative, it is positive sign.
and negative cosine.
جماعة والله teacher مش هنا.
Sorry for disturbing. So yeah, the integration of sine is negative cosine, and for the cosine is positive sine. Now, what is the integration of tan secant? It is secant x plus c. Of course, secant cotan. It's negative cotan. Sorry, negative cosecant x plus c. Now, derivation of secant square, tan x plus c. And for cosecant square, it is negative cotan x plus c. This is for the, as I told you, you can only write the table of the differentiation and opposite or write the inverse of them for the integration. But the only important here for me, x to the power r. How can we find its integration? Let's have now these examples here. What is the integration of x squared, x cubic, 1 to the power x, 1 over x power 5, and square root of x? Let's start now with the first one here. X squared. X raised to the power 2 plus 1 over 2 plus 1 plus c. Now, it will be x, 2 plus 1 is 3 over 3 plus c. So it's x cubic over 3 plus c, or you can say it is third x cubic plus c. Look at the second one now here. X, here the exponent is 3. So I will say 3 plus 1 over 3 plus 1 plus c. Now, 3 plus 1 is 4. So x raised to the power 4 over 4 plus c. Or you can write it also as 1 over 4 x to the power 4 plus c. 1 over x to the power 5. I write it as x to the power as an integration of x to the power negative 5 dx. So I will put x then. Now where's the exponent here?
Negative 5
Negative 5
plus 1.
So I will say now negative 5 plus 1 over negative 5 plus 1. So it is x to the power negative 4 over negative 4. That means I can write it as negative 1 over 4x to the power 4. Why? When I write down x to the power negative 4, I write it as x to the power 4. And then the 4, keep it in denominator and put the negative sign up. So it's like negative 1 over 4x to the power 4 plus c. Is it clear?
Yes. Yes.
Yes, teacher.
Now the last one here. The integration for square root of x is, first I can write it as integration of x to the power half dx. So I write it as, I will convert it to be as x raised to exponent. So then x half, sorry, half, I write it as half plus 1
Plus 1 over
half
half plus 1
plus c.
plus c.
Then it's half x, sorry. Half plus 1, it's 3 over 2 over 3 over 2 plus c. How can I write it now? 3 over 2, I will write its reciprocal, which is 2 over 3. and x to the power 3 over 2. As I told you before, if we have an x to the power m over n, I will write it as m inside and n outside. So here x to the power 3 over 2, how can I write it?
Cubic root of
Square
Square root of x cubic.
square
x to the power of n of 2
X cubic root of x squared plus c. So it is 2 over 3 cubic root of x squared plus c. Is it clear now?
Yes.
Yes, teacher.
Now let's have many or more examples here. Evaluate the integral by rewriting the integrand appropriately if required and applying the power rule. A. Here now. A integration of x to the power 8 dx. Here, I will say x. Now, where's the exponent? It is 8.
8 plus 1.
So I will say 8 plus 1
Over 8 plus
8
1
plus 1 plus c.
plus c.
That's mean x to the power 9 over 9 plus c. The second one, b. The integration of x to the power 5 over 7 dx is x. Now here I have 5 over 7. The exponent here is 5 over 7. So what I have to do, I will add it to 1. 5 over 7 plus 1 over 5 over 7 plus 1. So it is x to the power 5 over 7 plus 1 over 5 over 7 plus 1. I will now try to simplify it. Let's write 1 now. As we know before in grade 6, if we have here 1, I want now to write it as a fraction. Look at the denominator here. We have 7. So I will make the denominator down 7, like the fraction. And since I make the denominator down 7, I will make the numerator up 7. Up here, also down, sorry, it is 7 over 7. Then after that, x, I will add the two fractions since we have the same denominator. 5 plus 7 is 12 over 7 over x, 12, sorry, without x. Plus c. So I write it as what the reciprocal of 12 over 7 is 7 over 12.
7 over 12.
And then
X to the
power 12 over 7, I can write it as, sorry, the 7 outside here and x to the power 12. So don't forget plus c. Is it clear?
Yes, teacher.
Okay. Now let's do c. X cubic square root of x dx. Here now, what did we have? We have to write them as an exponent, so we need to simplify them. X to the power 3 times square root of x. It is x to the power half. I can write it as x to the power half dx. Then, let's continue. Here, as we know before, if we have the base, the two bases are the same. So, and they are multiplied. What can I do with the exponents?
Add.
Add them,
Yes.
exactly. So 3.5 dx. And 3/2, I can write it as, let's write it now as a fraction, not as a mixed number. So I will multiply, then add. So 2 times 3 is 6, plus 1 is 7 over 2. So I can write it as 7 over 2. By now, I didn't integrate. Now I will integrate. So it is x. Now 7 over 2 plus 1 over 7 over 2 plus 1. Then, as I did before here, the 1, I can write it as, with the exponent, since sorry, here I have a whole number added to a fraction. So I will look at the denominator of the fraction. It is 2. So since I write, or I multiply the numerator down by 2, I must multiply up by 2. Then I will add them, x to the power 9 over 2 over 9 over 2.
9 over 2.
So I can write it now
Plus
as 2 over 9 square root of x to the power 9 plus c. Is it clear?
Yes, teacher.
Yes, teacher.
Okay. Let's solve now. 10a. The integration of cubic root of x squared dx is, here now, how can I write it? I told you x to the power m over n is the nth root of x to the power m. Here I want to do the opposite, the converse. What I have to do? X to the power what? 2 over 3 or 3 over 2?
2 over 3.
2 over 3. So I want now to write it, to integrate it. X to the power 2 over 3. So it is x to the power 2 over 3 plus 1 over 2 over 3 plus 1. 1 over 1, 1 over 1. There's a number added to the fraction, times 3 times 3 times 3 times 3. Why 3? Because the denominator here is 3. So it comes like x to the power 2 over 3 plus 3 over 3 over 2 over 3 plus 3 over 3. 2 plus 3 is 5 over 5 over 3. Then its reciprocal is 3 over 5 cubic root of x to the power 5 plus c. Is it clear?
Yes, teacher.
Yes, teacher.
Okay, now B and C will be your homework. I will post it in the discussion room. I want you to solve it, and tomorrow I will solve it on in the virtual classroom. Okay, I want you to solve B and C.